Hi guys, my name is Tensor. Welcome to another Flutter animation tutorial video. In today's tutorial, we're going to be looking at physics-based animation in Flutter. In the last tutorial, we talked about tween-based animation and the basics of building animation components inside of Flutter. In this tutorial, we're going to look at another type of animation. We're going to build a box that you can slide up and down that will essentially act like a spring and a fluid at the same time. And here's what the end product will look like. If we pull up on the box, it will sort of stretch out, and when we let go, it will then snap into place. And if we pull down, it will sort of go in a concave shape, and when we let go, it will snap into place again. And you can see if we pull to the side, the curve just kind of changes, and we can do the same when we pull it down as well. In this project, we're going to be using a few ideas that we haven't really looked at that much inside of Flutter just yet. So fair warning that I will explain these as much as I can, but I would like to do more in-depth tutorials about some of these ideas. There will also be quite a few physics and math concepts inside of this tutorial that unfortunately I will not be able to go over in a large amount of detail. Hopefully you guys will be able to research these concepts on your own if you really want to. Alright, so let's get started. There are two major libraries that we need to import. We want to import Flutter Physics and we want to import Dart Math. So Flutter Physics exposes a bunch of physics libraries in Flutter, whereas Dart Math gives us some of the core mathematical libraries from the Dart language. I'm also going to create a constant color, and this will be the color that we're going to be passing into our painter to paint our physics object. Alright, so now let's build out the skeleton application. In our MyApp class, we'll have our build function return a material application. We'll give it a title of spring box, and then we'll give it a theme data, and we'll give it primary colors, which will be colors red, and then we'll have our home point towards a class called homepage. Our homepage will extend a stateless widget, and in here we'll build out our scaffold and basically the constructs that we're going to use to create our application. Our home page will contain a scaffold, and then inside of the body we'll have a padding. We'll put in edge insets only, and we want to make it so that we have more padding on the top and bottom rather than the left and the right. So left and right will have 10.0, and then the top and body will have double that, so it'll be 20.0. Then the child of this will be a class called PhysicsBox, and this is the class that will contain all of our state and stuff, and this is the class that we'll use to create our physics animation in. Our physics box will extend stateful widget because we want to have state inside of this class. Our physics box needs one property called box position, and this will be the position of our box relative to the normal position of the box. So this will be a percentage based position, so if it's like 0.5, then it will be about 50% the size of our box. We'll make the default of this be 0.0. And then we'll create our createState function, and we'll point this towards a class called boxState. For boxState, we want to extend state with PhysicsBox in it, and because this is an animation, we need to provide the ticker provider state mixin as well. And then we want to create two doubles. One is the box position, so this is again our box position, and then we have another one called box position on start. And this will be a variable that we'll use to hold the last box position after the user starts to move the box around. And then we need to have two offsets. Offsets are essentially XY pairs, so they're like coordinates on a Cartesian plane. We have one called start, and this will be the start point where the user clicks on the box. And then we have one called point, and this will be the actual area where the user is dragging the box around. Then of course we need our animation controller, and then we'll need what's called a scroll spring simulation. And this is the object that holds most of the logic that will give our box the springing animation physics and stuff. Then we want to override the initState function for this class. So we call super initState, and then we're going to set our box position equal to widget.boxPosition. Now widget allows us to get the box position from our PhysicsBox class. So anytime you see this widget keyword, it's essentially just getting a property from whatever we're wrapping with this state class. And this allows us to essentially use box position as a property when we instantiate PhysicsBox into our widget tree, and then it will be passed into our box state class. We also want to instantiate the simulation. We set simulation equal to a scroll spring simulation, and in here we pass in 4 values. One will be the spring itself, which is a description of the mass, stiffness, and damping of the spring. Then we have the start value, the end value, and the actual velocity. We can use the spring description object that comes with the Flutter physics library. If I hover over this, you'll see what it is. It creates a spring given the mass, stiffness, and damping coefficient. In this particular case, we're just going to put 1.0 in for each of these values. Next, we want our initial start value to be 0.0, and then we'll have our initial end to be 1.0, and of course the initial velocity we want to be at rest, so we give it 0.0 as well. Like with our tween animation, we need to instantiate our animation controller and give it the vsync object. We also want to add a listener to this animation controller. For our listener, we're just going to print out the simulation x with our controller value inside of it. So this is using string interpolation. Basically all we're doing is we're printing out the position of our object at a given time. Alright, so now let's override and create our build object. We're going to create a gesture detector. Now this is pretty self-explanatory. It allows Flutter to detect various different gestures that the user makes. In our case, we want to detect gestures where the user is panning the screen up and down. However, there are a whole bunch of other gestures that we can detect with this particular object, and I'm going to go into much more detail about this object in a later tutorial. So here's the basic skeleton of this particular object. We have our gesture detector, and then we're going to have an object called a custom paint. Custom paint is a widget that delegates its painting, and we're going to create another class to actually paint out this object, and then inside of it we'll have just an empty container. Before we create that object though, we need to create the functions that we want to have run when the user does various gestures. So first we'll create one called start drag. This will take in the drag start details object, and it will return nothing, so it has to be void. Our start drag function will take our start offset, and then we'll take our context, and we'll run a method called find render object, and this will try to find the object that we're rendering, which in this case will be the widget with the custom paint and the container inside of it. And we want to cast this widget as a render box. Basically all we're doing is we're taking our widget and we're converting it into something that can be rendered on a coordinate plane. Then we want to convert its coordinates to a more local set of coordinates by calling global to local, and then we're passing in the drag details and we're calling the global position. So this will find the global position and then it will make it into something a little bit easier for us to deal with. Then we also just want to take our box position on start and set it equal to our box position. Now we want to create a function called onDrag, and this is for when the actual object is being dragged around by the user. For our onDrag, we want to call the setState function because we want our widget tree to actually update. Then we want to take and we want to do what we did with our start, except this time we're going to do it with our point. So we take our context, we find the render object, and then we convert it into a render box. And then we call global to local on it with the details global position inside of it. And we're going to set this equal to our point offset. Then we want to create a variable called the drag velocity. We'll take our start y component and then we'll subtract it from our point y component, and this will give us the actual velocity. Then we want to take our drag velocity and normalize it. So we'll take our drag velocity and we're going to divide it by our context.size.height, which is the actual widget size's height. And then we're going to call clamp on this so that our number will be between 1.0 and 1.1. And then we'll take our box position and we'll take the box position on start. We'll add it to our normalized drag velocity, and then we'll clamp this between 0.0 and 1.0. Now finally we want to create an endDrag function. And our endDrag function is the function that executes when the user lets go of the box. We call setState, and all we're going to do is set our start and our point offset to null, and then our box position on start as well to null. Let's go up to our gesture detector and then key all of this in. And what we want to do is put these in for the properties onPanStart, onPanUpdate, and onPanEnd. The way that we're doing things in this particular class is not how the animation is going to actually look to the end user. It's just sort of an approximation of the background behavior of the object. This kind of concept is not really uncommon inside of animation and rendering and stuff like that. In fact, this happens a lot in games. Oftentimes in games you have large boxes and things that are invisible, and they act like hitboxes and stuff to detect collision, and they're based on approximations of the polygons that the player can actually see inside of the game. In this way, we sort of have our box that moves up and down, and the box that moves up and down doesn't morph like the animation does. Instead, what we do is we create a custom painter that will actually paint things so that they look like they're moving in that way. So inside of the custom paint object, we're going to create what's called a painter, and we'll call this our box painter. So this is another class that we have to create, and it's going to extend custom painter. Inside of our box painter, we want to create a bunch of properties. So we have box position, and then we have our box position on start. These are two from our other object. Then we're going to have the color of this object. We also want to have an offset, and this will be the point that the user is actually touching, much like the other point that we have in our other object. And then we're going to have two paint object variables. These paint objects are basically the description for how to paint things on the actual canvas. And so we have what's called our box paint, and this will be the main paint style and color. And then we also have our debug or our drop paint, and this will be a paint color that will pop in if we do run into a problem. So first we want to initialize our box position on start, our color, and then our touch point. We'll give our box position and box position on start 0.0 as their defaults. The color will default to colors gray, and then our touch point we'll just leave alone. We also want to set up our box paint and drop paint. So inside of our constructor, we extend this. We say box paint equals a paint object, and drop paint also equals a paint object. And then we open up some curly brackets, and we're going to set up our box paint color to this color, and then our box paint style will be painting style.fill, so this will fill out the entire box. Then the drop paint will be colors.gray by default. Drop paint style will also be paint style.fill. Inside of this object, we want to override a function called paint. So every single time we re-render the object, it will call this paint function, which will then paint it out. And this is something that will get called in every frame of our application while the user is dragging the object up and down. With this function, we pass in a canvas. Now the canvas, if we hover over it, you can see is an interface for recording graphical operations. It's essentially just a representation of our widget as a canvas object or as a object that we can paint on. And then we have our size, which is a 2D floating point. So first we're going to call on our canvas, then we're going to call clip rect, and this will make it so that our canvas only paints within a certain set of parameters. And inside of this we're going to call on the rect object, and we're going to call the method from left, top, width, and height. And then this will clip the rectangle to a specific set of parameters. Inside of this function we want to just put in 0.0 and 0.0 for left and top. And then for our width and height, we want to put in size.width and size.height. So now we want to create some more final variables inside of this function. First, we'll create our box value y. This will be the y coordinate of the box itself. We get our size.height, and then we subtract this from size.height times our box position. We also want to create the previous box value y. This will be the same exact thing, at least to start. Then we need to get our midpoint y. We take our box value, we subtract our previous box value, and then we multiply all this by 1.2 plus our previous box value. And then we want to clamp this between 0.0 and then the actual height of our box. Alright, so now we're going to create 3 points. These are like offsets. They have x and y. We have the leftmost point, we have our midpoint, and then we're going to have our rightmost point. For left and right, these are going to be somewhat static. Left will be negative 100 for the x value, and then the previous box value y will be its y. And then right will be size.width plus 50, and then the previous box value y will be its y as well. We want this to be on the top of our box So we get the left corner, the top left corner, and then the top right corner of our box. Then for our midpoint, we want to check to see if it's being moved around first. So we check to see if our touch point is not equal to null. And if our touch point is moving, then our mid is a point with the touch point x for our x value and then our midpoint y for our y value. Otherwise, the mid is just going to be our size divided in half and then our midpoint y. So this is just the middle top point of our box. Then we want to create what is called our path. A path is a complex one-dimensional subset of a plane, and it's essentially just a bunch of subpaths and a current point. And we can sort of use this to represent the actual front of our box. So as the user is pulling it up, it becomes sort of an arc that is convex, and as they're pulling it down, it becomes an arc that's concave. I know this is sort of complicated, but the path itself is just the edge of our box when the user is moving it around. To explain this path and how it's working, I've opened up Paint and I've drawn a square to represent our object. So first we move our path to the midpoint, which is where the user is essentially dragging the object. So they're either dragging it up or down. So the midpoint will be along a line that goes like right through the middle of the top here. Then we have what's called a Quadratic Bezier, which is a curve, and the curve starts at mid x and mid y, and it goes to left x and left y, and then it has what's called a control point of mid x minus 100 and mid y. So we'll start around here, and then we come all the way down to the left side. So with our control point, the curve will look something like this. So you can see this sort of curves downwards like that if it's moving upwards. And if our curve is moving downwards, say like here, the curve would be curved downwards like that. Then we have this line 2, 0.0 size.height, and this would be the current corner on the left side. Say with this curve that's going upwards, the corner would just be here. Let me delete this other curve. So yeah, comes down like this, and then we have a line that's just here. So it's just essentially a dot. And then we move back to the middle, and we create another Bezier curve, which starts from the middle and goes all the way to the right. So in this case, it'd be like this. And then it has our control point of mid x plus 100. So it would move up like that, and mid y. And then we have another line 2, size.width and size.height. So this would be the top right corner. So the line would be somewhere around here. And then we have another line that goes to the other corner. We start at the right corner and we draw all the way to the left corner like this. And then we close our path. So then of course we want to draw the path. So we take our canvas and we call draw path. We pass in our path and then we pass in the box paint. And then if this doesn't work out, we call canvas draw circle. With our offset around the right.x and the right.y, we put in a radius of 10.0, and then we put in our drop paint, which is our debug paint. To finish this object, we need to override a function called Sugary Paint. This is a function that gets called every single time the renderer needs to figure out whether or not it needs to repaint the object. And we're just going to perpetually return true. So this will always repaint the object no matter what. Okay, so now let's jump back up to our build function inside of our box state class. And inside of our box painter object, we need to now define a bunch of properties. We need to put in our color, so this is the color that we want to paint our box with. This is the color that we made constant at the top. Then we need to put in our box position, which is our box position, then our box position on start. And this is a special syntax, this double question mark. It checks to see if box position on start is equal to null, and if it is, then it passes in box position. Otherwise, it passes in box position on start. Then we want to put in our touch point, which is just our offset point. We should be able to now run this, and it should work properly. So to run this, I'm just going to hit F5. This was fixed in the most recent version of Flutter. Alright guys, so there were a few errors that I had to debug, but here is our application. So if we pull up, you can see it sort of pulls up in a curve, and then when I let go, it then normalizes. And when I pull down, it pulls down in a curve, and when I let go, it normalizes. Okay, so let me go through the debugging that needed to be done. So I forgot to put a container around the padding. Also down inside of our paint function, the previous box value y, I had this as the same equation as the one above, where it was multiplied by box position. It needs to be multiplied by box position on start. Alright guys, well I hope you enjoyed this tutorial. I know I didn't really explain the mathematics or the physics behind what we were doing here. Hopefully you guys will be able to sort of go and look up the stuff if you really need to figure it out. But I hope this sort of gave you a good idea of how you can make like a physics style animation with Flutter. Anyway, if you like this tutorial, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the box below. And if you dislike this video, then by all means downvote it as much as you like. Have a good night, guys.